Here we have a right triangle with legs A and B, hypotenuse C, and if theta is our angle, then opposite would be here, which is side A, adjacent is side B, and of course opposite the right angle is our hypotenuse, and that would be side C. So let's see, we've got theta here. Sine of theta is opposite over hypotenuse. That would be A over C. And the cosine of theta is adjacent over hypotenuse. That would be B over C. Now, we have the Pythagorean theorem, a squared plus b squared equals c squared, which works for all right triangles. Now, thinking about changing this and how does that help us with trigonometry, if we were to divide everything by c squared. So we have a squared divided by c squared plus b squared divided by c squared is equal to, here we have c squared divided by c squared. What we can now do is, because we know that a squared over c squared, if we square both sides here, we could rewrite this as sine squared of theta. And here we have b squared over c squared. Going to come back over to here. So we have cosine squared of theta, and here is c squared divided by c squared. That equals 1. This is our first Pythagorean identity. And it originates from the Pythagorean theorem. And we are using then our terms sine and cosine with respect to the sides to use this. And so from that we can also derive a couple of other Pythagorean identities. So the first one is sine squared theta plus cosine squared theta equals 1. Now if we divide everything by cosine squared of theta. So let's see, we're going to take sine squared theta divided by cosine squared theta plus cosine squared of theta divided by cosine squared theta. And that's going to equal 1 divided by cosine squared theta. This is where we can now do some converting. We know that sine over cosine is tangent. So in this case we would say that that is tangent squared theta. Of course, cosine divided by cosine here, we have 1. And then 1 over cosine is secant, so we could say this is equal to secant squared theta. This is our second Pythagorean identity. We continue. Let's go back to the original. Sine squared theta plus cosine squared theta equals 1. And now let's divide everything by sine squared theta. Again, we know sine squared divided by sine squared gives us 1. Cosine divided by sine, that is cotangent. So we have cotangent squared theta. And then 1 over sine is cosecant. This then is our third Pythagorean identity. Can also be written as cotangent squared theta plus 1 equals cosecant squared theta, to give us 3 Pythagorean identities. So we'd already discussed these fundamental identities. Here we have tangent of theta is equal to sine over cosine. We just use that in helping derive some of our Pythagorean identities. We also have cotangent of theta is equal to cosine over sine. Then we have our reciprocal identities, where we have the cosecant of theta is equal to 1 over sine, secant is equal to 1 over cosine, and cotangent is equal to 1 over tangent. And then we're going to add those 3 Pythagorean identities to these fundamental identities. We also have what is called the complementary angles theorem. Now, cofunctions of complementary angles are equal. That is our complementary angles theorem. Now, cofunctions. When we're talking about cofunctions, sine and cosine are cofunctions. secant and cosecant are cofunctions, and tangent and cotangent are cofunctions. So when we're talking about cofunctions of complementary angles, we could be talking about the sine of 40 degrees. That's going to be equal to the cosine of 50 degrees, because we have these two cofunctions and then we have these complementary angles that add up to 90 degrees. So then we could also say, for example, that the secant of 30 degrees would be equal to, here's our cofunctions, so cosecant of 60 degrees. Or if we're talking about the tangent, tangent of 25 degrees would then be equal to the cotangent of 65 degrees. And that is our complementary angles theorem. So this is how we're going to use all of these different identities. Here we're going to solve some problems using identities, no calculators. So here we have the secant squared of 28 degrees minus the tangent squared of 28 degrees, and we want to find an answer for this. Now remember, we just discovered that we have our Pythagorean identity, tangent squared theta plus 1 is equal to the secant squared of theta. If we subtract that over to the other side here, so I'm going to subtract tangent squared theta from both sides of my equal sign, I end up with 1 is equal to secant squared theta minus tangent squared theta. Secant squared theta minus tangent squared theta. That's what we have right here. And that's always going to equal 1. So the answer to this would be 1. Let's look at another one. Here we have tangent of 10 degrees times a cotangent of 10 degrees. Well, we know that the cotangent could also be written as 1 over tangent. So we have tangent of 10 degrees times the reciprocal here, 1 over tangent of 10 degrees. That's going to also equal 1. Here's another problem. We have cotangent of 25 degrees minus cosine of 25 degrees over the sine of 25 degrees. Let's see, we know that cosine over sine is also cotangent. So cosine of 25 over the sine of 25 would be cotangent of 25 degrees. So here we have cotangent of 25 minus the cotangent of 25. That would equal 0. And then here's another example. We have cotangent of 25 degrees times the cosecant of 65 degrees times the sine of 25 degrees. So if we rewrite cotangent of 25 degrees, let's say we write that as cosine of 25 degrees over the sine of 25 degrees. And then we still have our cosecant of 65, and we have our sine of 25. Okay, so this is basically over 1. As we multiply, these two would divide out. So now we're left with cosine of 25 degrees times the cosecant of 65 degrees. Let's see. Remember, we just talked about our cofunctions of complementary angles being equal. Our cofunction of cosecant would be secant. So we could now change this, instead of 65, secant of 25 degrees times the cosine of 25 degrees. Remember, secant and cosine are reciprocals. Rewrite this again as 1 over cosine of 25 degrees. That's still times the cosine of 25 degrees. Now we multiply across, and again this is equal to 1.